Hello everyone, good morning, good evening, good afternoon. The sum that we're going to be solving today is unique paths. So this is a classic DP problem and it is pretty much straightforward. So let's just get on with the solution. Uh, there is a robot on M cross N grid. The robot is initially located at the top left corner, that is grid 00. The robot tries to move to the bottom right corner, that is grid M minus 1 N minus 1. So this basically says that it is a zero indexed grid, which is but obvious. We're computer engineers. The robot can move either down or right at any point in time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases generated are so that the answer will be less than this. Matlab, everything is in integer, it will not surpass the uh, length, the max value of integer. Basically, that is what this statement is trying to say. So let's just take an example. What they have given is m is equal to 3, n is equal to 7, output is equal to 23. So for this particular problem, the answer is 28, and for this particular problem, the answer is 3. So let's just go and solve it out. So here, yeah, so here our m is equal to 3 and n is equal to 7, is that's what they've said, and our answer is 28, right? So basically, what is the most brute force thing that comes to your mind? Because in an interview, you have to think, you have to tell your thought process. Directly jumping to the solution will not be going to help you, will not be helping you in any which ways. So yeah, so basically, what the first thing that comes to my mind is I need to count, right? So I can go right, then I can go down, then I can go right, then I can go down, then I can go right, 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 and then finally reach here. This is one way. Then I can go down, right, down, down. I cannot go up, I cannot go up, I cannot go up. So I can go down, right, right, like this. I can go this. Oh, sorry. I can go this, I can go this, I can go this, I can go this, I can go this. There are many possible ways, right? So basically, we can just run a simple DFS. We can run a simple DFS. So like, it takes a step, then runs DFS to the next step, then runs DFS to the next step. So you have to run DFS for each step from a particular tile. So from here it takes this step, from here it takes this step, runs a DFS here, runs a DFS here, right? So there are multiple steps. Now see, now from here it takes this step. Now this is repeated, right? So since DFS is very costly, so we can cache, we can memoize. How does memoization work? Here we store the result of this, right? So when I did this and calculated a value for this, so like let's say this runs recursion, this runs its DFS and gives me answer as x. So we store this x so that whenever it comes here, it knows that it knows that the answer is x, so it does not run a DFS function again from here. So that is how a memoization solution would work. It's basically a DFS solution. So our brute force approach would just be DFS, or then our better approach would be DFS plus cache or memoization, whatever it is you call it, DFS plus cache. Then the third thing that comes to our mind is DP. This is the most optimal. Now how DP? How DP? How are we going to do DP? So one thing you noticed. So now whenever DP comes into picture, let's say this was my final state, right? I need to find this. Now basically what we are counting, what were we storing in this cache is the result, right? Is the result that which came after running DFS from here. Now if you see that we just have two options we can take. We cannot go up, we cannot go up, we cannot go left. We can only take a right, or we can only go down, right? Now if you see, to it is a repeated thing, right? It is a repeated thing. So like y- y- to go from here to here, you will somewhere encounter this, somewhere encounter this. So we break it down into smaller parts, right? So from here to here, here to here, right? So basically that is how DP works. We are breaking this down into multiple parts. So now if you see that if we take the second example that they have given, the second example, mn, this is 3, m is 3 and n is 2, right? This is the example that they've given, right? So what we can see here, we can go right, down, down, this is one step. We can go down, right, down, this is one step. We can go down, down, right, this is one step. So our answer essentially is just 3, because there are just 3 ways in which you can accomplish this, right? So we'll have to return this, we'll have to return this, right? How did this come? Now if you carefully see, to reach here, you will either come from here or you will come from here. Do you get me? That to reach the final step, since you cannot come from here, diagonals are not allowed, diagonals are not allowed. So this step you cannot do, you cannot do this step. You can either come from here or you can come from here, right? So essentially it this is nothing but an addition of this and this. This is nothing but an addition of this and this, because this each cell, let me just write it down, each cell stores the number of ways needed, not needed, number of ways that exist to reach the cell, to reach the cell, to reach the, oh my god, to reach the cell, right? So you get my point, right? To reach here, from here you can take one step and from here you can take one step, right? So essentially to reach here, how many steps do you take? Let's say x. To reach here, how many steps do you take? Let's say y. So to reach this point, you can take x plus y steps, you can take x plus y steps. So now if I tell you, to reach here there are one way, there is this is one way and this is another way, so we can do 2. And to reach here, it's just one, you cannot do this, right? You cannot take a left, so it's just a single way. So to reach here, it's 1, so 2 plus 1 gives you 3. Now you will think, so this is 2, to reach here, how many steps, how many ways are there? There is one way, there is two way, right? So from here and here. So to reach here, there is just one way, same with this, and since you're starting from here, you can just ignore this part, and or you can, to reach here there is just one way, because you're already starting from there, right? So this is how our DP table would look like. Now if you carefully observe, the first row and first column are all ones. Why is that? First row and first column will always be 1. So my first row and first column will always be 1, because it is very simple to understand that to reach this point there is just one way, that is going right. There is no zigzag way, there are no multiple ways to reach the same row from the start point, right? So to reach here also you just have to take a bunch of rights. To reach here, bunch of rights, a bunch of downs. To reach here, a bunch of downs. To reach here, a bunch of rights. To reach here there are multiple combinations of rights and downs, right? So that is why this is a little complex to calculate than this will always be 1, because this is just a bunch of rights, this is just a bunch of downs. So basically this is our DP initialization. I hope you understood how we initialized the DP and why did we take that decision. Why did we initialize all of this as 1? Now it's pretty much straightforward, since we know that we have to calculate the sum of the top and left digits, top and left cells. So it's just simple. 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 4 plus 1 5, 5 plus 1 6, 5 plus 1 6, 6 plus 1 7, 2 plus 1 3, 3 plus 3 6, 6 plus 4 10, 10 plus 15 21 and 28. So we return 28. We return 28. I hope you understood how this happened. I really hope you understood how this happened. So now let's quickly code it up. Let's initialize the DP. Int DP is equal to new int m into n, because that's just our grid. DP at 0, 0 is equal, oh my god, what just happened? 0, 0 is nothing but 1. For int I is equal to 0, I is less than n, I plus plus. What is n? N is the number of rows. So we initialize all the rows. Why did we do 1? Because we have already initialized the zeroth part as 1. I is equal to 1. Then we do the same thing. Again, but this time for the columns. And now for int I is equal to 0, I is equal to 1, I less than n, no, where I less than m, I plus plus. For int j is equal to 1, j is less than n, j plus plus. Now dp at I comma j is equal to dp at I minus 1 j plus dp at I and j minus 1. This is essentially our formula, and in the end we return dp at n minus 1 comma n minus 1. My bad, this is m and not n. I hope this works. There you go, our test case has been passed and we submit the solution and this should work. Yeah, there you go. This is our DP problem and I hope you all understood what we did. Thank you so much and have a great day.